This is the second part of our 3-3 lesson, all about slope and rate of change. So in the last lesson, we went over what slope is and how to find it mathematically. It's the change, the rise and rise over run when you're looking at the graph of a linear equation. And we find it mathematically by finding the change in y over the change in x. Meaning, when we have two ordered pairs that lie on a linear equation or that are solutions to a linear equation, we take the y values and subtract them. That goes on top of our fraction. And we take the x values and subtract them. That goes on the bottom. And that gives us a fraction which represents the rise over the run. Okay, so our special cases are horizontal and vertical lines. If we have a horizontal line, let me zoom in a little. This looks super far away. Sorry if it's blurry for you guys. If we have a horizontal line goes side to side. I tried to kind of draw one here, like the horizon. Okay, when we use the slope formula, change in y over change in x, if you think about it, the y-axis goes up and down, right? So if we're graphing a horizontal line, does it go up or down anywhere? No, it doesn't go up or down. It just goes side to side. So the change in the y values, when you're graphing, there's no change. There's nothing. So we put a 0. And then the change in the x values, there will be a change side to side. So you'll get some number, right? So if we have 0 over a number, doesn't even matter what this bottom number is. What's 0 divided by anything? 0, right? So the slope of a horizontal line will always, always, always be 0. So let's look at a couple examples here. We've got this graph. This is a horizontal line. It gives us the ordered pairs here, -2, 3, and 3, 3, right? And what do we notice? -2, 3, and 3, 3. What do we notice is the same in these two ordered pairs? The y values, right? When the y values are the same, we know it represents a horizontal line. So if we used y minus y over x minus x, 3 minus 3 over -2 minus 3, we would get 0 over a number, whatever it is, doesn't really matter. And 0 divided by any number is just 0. The slope is 0, right? Same thing here. The y values are the same, so we know this is going to be a horizontal line when the y values are the same. So on the top of our slope formula, y minus y, I'm going to have 9 minus 9, which is going to be 0, right? On the bottom, it doesn't matter which order I do it in. I'm going to do 5 minus 3, 0 over 2, and 0 divided by anything is just 0, right? The slope of a horizontal line is always 0. Last one, this one involves decimals, but the y values are still the same, -0.9, -0.9. We don't even have to do the formula, right? Once we know they have the same y values, we should automatically know it's a horizontal line and it's going to have a slope of 0. But we can go ahead still and do the math. All over 0.2 minus 0.5, or you could have done it the other way, that's fine. Double minus becomes a plus. -0.9 plus 0.9 is 0. 0.2 minus 0.5 equals -0.3. And 0 divided by anything is just 0. So horizontal lines always have the same y values, and the slope is always 0. Here's the other special case, a vertical line. So remember, a vertical line goes up and down. Some people get those confused. I know I was one of those people once upon a time. I would always get those confused until somebody told me so obviously that a horizontal line is like the horizon. Horizontal, right? Horizon goes side to side. When you watch the sunset on the horizon, it goes side to side. So vertical is the other way then. It's up and down. All right, so if we think of it the same way, for slope, we find the change in y over the change in x. For a vertical line, the change in y is a lot, right? It's going to change. It goes up and down. It literally changes. So we're going to have some number on top, but the bottom is the change in x, or the run. Does our line go side to side anywhere if it's vertical? No, it literally just goes up and down. It doesn't go side to side at all. So there is no change side to side. So the change in x is 0, right? So we're going to have some number over 0. And mathematically, in math, as you guys have always learned, mathematically, you cannot have a fraction with a 0 in the denominator. It doesn't exist. I know people want to argue, why? And I'm sure there's a great explanation, a basic explanation. I can find that out for you guys. I don't know off the top of my head. But in math, you cannot have a fraction with 0 on the bottom. So, therefore, a slope of a vertical line, since it's always going to have 0 on the bottom, we say that it's undefined. I just got a phone call on my phone, so I reset my video, sorry. All right, so here are a few examples. Here is the graph of a vertical line going up and down. We have our two ordered pairs, and they are -3, 3, and -3, -1. Now, what do we notice is the same in the ordered pairs of a vertical line? The first number, the x value, right? The first number is always the same. So when we do our slope formula, y minus y over x minus x, -1 minus 3 over -3 minus -3, minus negative becomes a plus. -1 minus 3 is -4. -3 plus 3 is 0. So we've got a nasty fraction with a big fat 0 on the bottom, and that is not possible. So this is an undefined slope. A fraction with 0 on the bottom does not exist, right? You can have 4 of one thing. You can't have 4 of 0. Then you wouldn't have 4 of it. You'd have 0 of it. This just doesn't exist. All right, number 12 here. Same thing. We've got two ordered pairs that lie on a vertical line. They've got the same x value. So as soon as you see two ordered pairs with the same x value, that should automatically tell you, okay, same x's. Change in x goes on the bottom of my slope. So if they're the same, there is no change. That's a 0 on the bottom of a fraction. Oh, this must be a vertical line, undefined slope, right? But we'll go ahead and do the math. So 10 minus 5 over 12 minus 12. 10 minus 5 is 5 over 12 minus 12 is 0. And there's a big fat nasty 0 on the bottom of that fraction. So this is undefined for our slope. There is no such thing as 5 over 0. And last one here, one more example. You guys can always pause the video and try it on your own. We can see clearly that they have the exact same number, -7, and for x. So automatically we know, okay, this must be a vertical line. There's no change in x, so the slope's undefined, but we'll do the math. Y minus y over x minus x. When you minus a negative, it becomes plus. 3 over 0, which is undefined. Cannot have a 0 on the bottom of a fraction. All right, and lastly, for this whole entire lesson for 3-3, rate of change and slope, I have 3 more problems we can kind of work on. We didn't really touch that much on rate of change, and in the book, it touches a little bit more on it. Basically, rate of change and slope are the exact same thing. There is no difference. We just call it the rate of change when it refers to a word problem. So when we're actually referring to units of measure and not just an equation with x's and y's. If we were talking about, gas mileage and the price of gas, or, I don't know, something like that. If we're actually talking about physical things, if it's a physical word problem referring to physical things, we call it the rate of change if we're solving for slope. But it is still slope. They are the exact same thing. Okay, so find the value of r so that the line passes through each pair of points and has the same given slope. Okay. So here what it's saying is before we used the slope formula to solve for the slope. Here it gives us the slope, but we're missing part of one of the ordered pairs, right? So we've got our x and our y, and we've got our slope. So my slope formula is y minus y. I'm going to do r minus 7 over x minus x. Since I started with r on top, I got to start with its partner on bottom. -2 minus 6. Okay? And so normally this tells me my slope. I solve for the slope. In this case, I already know what the slope is. It's going to be 1 over 2. What I don't know is r. So I'm just going to start simplifying as much as I can. I've got a proportion here. I've got two fractions set equal to each other, so I know I can cross multiply them to solve, right? So here, -2 minus 6 is -8. So I'm going to have r minus 7 over -8 equals 1 over 2. Then I'm going to cross multiply both of these. So I'm going to have negative 8 times 1 equals 2 times r minus 7. And now I can solve. Negative 8 equals, I'm going to distribute 2r, bring down my minus sign. 2 times 7 is 14. I'm trying to get r alone, so I'm going to add 14 to both sides. So I'm going to get 6 equals 2r. Divide both sides by 2, and r is going to equal 3. So we still used our slope formula, even though we already knew the slope and we just didn't know an ordered pair. Same thing here. We don't know this ordered pair number, but we do know the slope. Negative 5 over 1. Remember, when the slope is not a fraction, you make it a fraction by putting it over 1. So I'm going to use y minus y, 2 minus r over, since I started with 2 on top, I start with negative 7 on the bottom, negative 7 minus negative 8, and a double negative becomes a plus. And I know the answer is negative 5 over 1. Okay, so now negative 7 plus 8 is 1, so I get 2 minus r over 1 equals negative 5 over 1. Since both of these fractions are, sporadically look up and notice I'm not even on the thing here. Since both of these bottom numbers are 1, they have the same denominator, that means the tops have to be the same. So I'm just going to not even worry about cross multiplying, and I'm just going to set 2 minus r equal to negative 5. Oops. Sorry. 2 minus r equals negative 5. And I'm going to subtract 2. Negative r equals negative 7. And if negative r equals negative 7, then that means positive r equals positive 7. Okay? And then last little word problem here, and back up a little bit so we can read it. And this file is in this folder if you can't read any of this. All right, sales. A daily newspaper had 12,125 subscribers when it began publication. 5 years later, it had 10,100 subscribers, so it went down. What's the average yearly rate of change in the number of subscribers for the 5-year period? Right? So what's the change? So we have two ordered pairs here. This is a word problem, right? So all it tells us is in year 0, right? In year 0, when it first opened, when it began its publication, year 0, it had 12,125 subscribers. Or we could say year 1. Let's say year 1. Year 1, it had 12,125 subscribers. So there's an ordered pair. 5 years later, so we add 5 to this, so now we're in year 6, it had 10,100 subscribers. So what's the change? What's the rate of change here? In other words, what's the slope? It's referring to number of subscribers in years. That's why we call it rate of change, but it's still just the slope. So we're going to use y minus y over x minus x. 12,125 minus 10,1 over 1 minus 6. And this is going to be 2,025 over negative 5. And then I'm going to go ahead and get a number. Since it's a word problem, I don't need it to stay in fraction form. It says, what's the average rate of change in the number of subscribers over 5 years? So 2025 divided by negative 5 equals negative 405. Negative 405, which means, what does that mean in context? They lost 405 subscribers a year in 5 years. The average rate of change, they went down 405 subscribers a year over 5 years. So they started with over 12,000 and they ended up with just over 10,000. Okay, all that was on slope. If you have any questions at all, let me know. Thanks.